Hello, everyone. Good afternoon. Today, I'm going to start a series of questions based on the board exams, in which I will be roughly covering all the topics all the topics with questions focused on the last 10-year exam papers that have been asked in the board exams. So, today we are going to start with circles since that is the topic we were just doing, and a lot of the ninth grade students who have gone through the videos, they would also get to see how questions what they are doing in grade ninth also are very relevant in grade 10th. So what you have studied in grade ninth is not completely relevant or completely useless. Please do not think like that. We are going to do circles first, then the next topic that we are going to cover is trigonometry. First round of recap, I'm thinking to keep only from the board exams. So all the last 10-year papers questions from circles, trigonometry, that is what my next target is. After that, we will build up on the other topics as well. My focus is not to touch upon the easier topics, at least not for now. If before the exams we have some time remaining, we'll try and cover those topics as well. But for now, my focus would be mostly on circles, trigonometry, quadratic equations, AP, ratio and proportion, equation of a straight line, similarity of triangles, surface area and volume. So the topics which are more loved by the students, and definitely more loved by me. I really like those topics. I'm 100% sure you will all agree to that, right? So circles is favorite of everyone, right? So without further delay, let's start with questions. I hope this thing that I'm going to start with probably helps you all in preparation for your exams. We are almost a month and 7 days from the exam now, from the board exams. So I hope this helps in your overall preparation. So let's begin with this question. So the first question that we are going to talk about is on your screen. It's a pretty ninth grade oriented question, I would say. They have said the chords AB and CD are respectively 24 and 10. That means these two parts will be 12 and 5 respectively. I think you all know that when you drop a perpendicular on the chord, it bisects the chord into two equal halves. You have all seen that theorem, right? So 24 becomes 12 divided into two halves. 10 becomes 5. Now the question says the radius is 13 centimeter. So this is 13, but so is this, right? Radius in one circle, you cannot have two different values of radius. So this is going to stay. Now we are going to apply Pythagoras theorem in triangle 1 and triangle 2. You have previously seen these questions in grade 9th explanations when I was talking about the chord properties of a circle. So this is a 2017 board exam question, ICSE. Okay, so it's kind of relevant. Please do not think it's only applicable to 9th grade. So I'm going to apply Pythagoras theorem in triangle OCM, and as a result, what will I get? 13 square is equals to 5 square plus OM square. So that is 169 minus 25 is equals to OM square. That means 144 is equals to OM square, and OM becomes 12. So this part is 12. Now we will move to triangle ANO, in which again I'm going to use Pythagoras theorem. So 13 square is equals to 12 square plus ON square. That means 169 minus 144 is equals to ON square, and therefore ON will be equals to 5. So what we have is OM and ON using Pythagoras theorem. There is no specific hardcore circle theorems being used here. I mean, this is pretty standard stuff. 3 marks question this was, I believe. So the distance between the chords is what they are asking, and the distance between the chords we have just figured out. 12 plus 5, which is 17 centimeter. And that's your answer. This was an easy question, pretty much a ninth grade question, I would say. It was asked in 2017, so roughly 8 years back. But still, a question asked in board exams is still relevant. We cannot ignore the importance of that question, right? Okay, I hope you have understood. This is purely based on ninth grade theorem. Let's move to the next question. Now, please remember there are two very important key points I will mention here, I would like to mention here, when you're solving questions from grade 10th, which involves tangent properties or which involves your chord related properties or chord and tangent mix properties, which we also call as our alternate segment theorem. So please understand, isosceles triangle is going to play a very, very important role. So when you draw a circle and there is a radius, there are two radii involved. Please remember that this is an isosceles triangle because both the radii are same. Both the radii are same. You can't have two different radii in a single circle. So remember that isosceles triangle will play a pretty crucial role moving forward when we are solving questions. And the second theorem that is going to play a massive role is alternate segment theorem. So this angle made between a tangent and a chord, this is how you will observe it. A tangent and a chord, the angle made between them is similar to the angle made by the same chord in a different segment. So if I made a chord, I made a minor segment and a major segment, right? So when I have two different segments, the angle made here between the tangent and the chord will be equals to the angle made by the same chord, but in the alternate segment, different segment. That's why this is known as alternate segment theorem. Now, let's move on to the question. So the question here is saying that AB and AD are bisectors. Now, bisectors also, guys, please remember there is one very important thing I would like to talk about. This is related to normal geometry. This is not really fancy stuff, but very normal stuff. If I draw a bisector, precisely what I'm saying is that these two angles are going to be equal, correct? I would request all of you to please follow this. When you have two equal angles, the moment they use the word bisector, please mark them as x and x. Please don't forget that we are very much comfortable with finding angles as x and x, y and y, rather than writing it as angle BAQ or a PAC or whatever, right? So using x and y's always helps. So the question says AB is a bisector of angle CAQ. So this is your CAQ. So AB is bisecting. So this both these angles will be x and x. Then AD is bisecting angle PAC. So PAC. Okay. So this whole angle will be bisected and they will become Y and Y. So I'm using two different letters because they are two different angles. We don't have any confirmation that these two angles are equal to each other. So we will use different letters. But bisecting, the moment you hear that word, any chapter, any geometry chapter, please mark the angles as x and x, y and y. It just helps your life. In general, it's a very easy thing. Now, let's try and see what has been given to us. They are saying angle BAQ is 30 degree. Whoa, that's something that makes things interesting. So we have this angle as 30 degree. PQ is a tangent. AB and AD are bisectors. Angle BAQ is 30 degree. So this is also 30 degree, guys. So AB, using alternate segment theorem, I'm going to mark a few things. So AB is a chord, correct? This chord I'm talking about. And here is your tangent, AQ. So if you notice here, this angle X, 30 degree, will be made by the same chord AB in alternate segment. So if you see the ends A and B are joining at D, and that becomes 30 degrees, right? So we have a 30 degree here. All right. We have 30 and 30 given to us. So first thing that they're asking us to prove is prove that BD is a diameter of the circle. Diameter means you have to prove, okay, so very important thing, when you have to prove something as diameter, just prove this angle as 90 degree. Prove that triangle to be a right angle triangle. Life becomes easier, guys. Trust me on that. Now, if this is 30 degree, this is also 30 degree, angle in the same segment. I hope you know that. So angle in the same segment looks like this. So this and this is equal, this and this is equal. So this has been already explained in the 9th grade theorems when we were doing it, okay? So we have 30 and 30, which is 60 degrees. So we have 120 degree here, correct? because triangle ABC is still a triangle, so it has to make 180 degrees, right? And also, if you notice, A, B, C, D is cyclic, correct? So if it is a cyclic quadrilateral, the opposite angles have to add up to what? 180 degrees. So angle B plus angle D has to add up to 180 degrees. I have a 120 here. So this whole thing should be 60, this whole angle. That means this is also 30, correct? So we have to prove BD as diameter. We still need to find um, the value of y here. Okay. Okay, so that's what is missing from what we have. Okay, so let's try and see if we can use the chord AD. Again, alternate segment theorem, guys. Okay, so we have the chord AD making this angle. So this can be known as, this can be called as y, right? Um, and so we have a 30-degree here. So y and y. So if you look at triangle ADC, we have y plus 60 degree. So we have y plus 60 degree is equals to 180. That means 2y is equals to 120. That means y is equals to 60 degree. And that means that this angle is 60 degree. So what am I getting x plus y as? 30 plus 60, which is 90 degree. That proves that BD is a diameter. Okay. So BD is making, if you see, I will draw that BD part separately here. So if you notice there, we have just proven this angle to be 90 degree, and this was your B and this was your D. So by angle in a semicircle property, BD becomes a diameter because the angle made by B and D, both the ends converged at the circumference, and the angle made by them was 90 degree. So part 1 is done. Second part says we have to prove ABC is isosceles. Is it? Okay, so I think we have already proven that. Triangle ABC, if you see, we have angle BAC is equals to angle BCA is equals to 30 degree each. So it is an isosceles triangle. Isosceles triangle, please remember, it's not just about proving two sides as equal. If you have two sides, if you have two angles also as equal, it is pretty much an isosceles triangle. So please do not get confused with that, all right? So I hope whatever I was explaining, alternate segment theorem, you have understood everything. It's a simple thing. You have to start observing with AB as a chord. So AB will make an angle 30 degree here, right? This 30 degree will create this 30 degree because angles in the same segment are equal, right? Now we have a 30 degree here. We had a 30 degree to begin with. So 30 plus 30 is 60. That gave us this angle as 120 degree. When this became 120, this whole thing had to become 60, and as a result this angle became 30, and from there on it just followed naturally. We reached a position where we could write y plus 60 as 180, and hence we have proven. So I hope you guys understood this question. I know it's a bit messy, but I have tried to explain it in as simple way as possible. I have tried to explain with all the diagrams taken out from the original question. I hope you have understood all. So let's move. I think we will move to the next question. Okay, so let's see what we have here. Um, okay, so we have been given that angle DAE is equals to 70 degrees. Okay, so DAE is right here, 70 degrees. So I hope you guys remember that in a cyclic quadrilateral, all opposite interior angles is equals to the exterior opposite angle. So exterior angle here is equals to the interior opposite angle. My bad, I was just blabbering something, sorry. So exterior angle is equals to the interior opposite angle. So this is 70 degrees. That means this is 70 degrees. Now, if that is 70 degrees, angle at center is what? Is always double angle at circumference if the arc is same, right? Now, if you see here, this angle will become 140. And then that isosceles thing I was talking about earlier. Triangle OAD is isosceles. I hope you can all guess why. Because OB and OD are both radii, and one circle cannot have two different radii. So they have to be equal. That means 140 makes this as 20 and 20. All right. Now let's move on and see what is the question asking. So they are asking the value of BCD. Angle BCD. Did we find it? BCD. Yeah, 70 degrees. How? Exterior angle property of what? Of cyclic quadrilateral, guys. Okay. Now, BOD. BOD. Angle BOD is 140. We've already found it because angle at the center is always twice. So, this theorem. Okay. So, I can make an arrow. And then angle OBD is 20. Isosceles triangle property. Please remember, okay? So like I told you when I was explaining you this question, that isosceles triangle where both the radius is included, this diagram, guys. Please remember, isosceles triangle is very, very important. Almost every second question related to chord and tangent properties are solved using isosceles. Sooner or later, you're going to encounter it. So I would request that please, whenever you see a circle question, try and keep an eye on if there is an isosceles triangle being made somewhere so that you can use the two angles as equal to each other. Okay, let's move to the next question. All right, so this one was clear. I think this was a purely cyclic quadrilateral question. So cyclic quadrilateral you study in grade 9th. Again, to reiterate my point, grade 9th circle theorems is super important, guys. Please remember these questions. I have not framed these questions. I have just picked it up from ICSE official website. So they are authentic board exam questions. So if they can give so much value to what you do in 9th grade, I think we have no rights to deny that. Okay. So cyclic quadrilateral, angle at center and circumference. This is all 9th grade stuff, pretty standard stuff. But please keep revising your 9th grade theorems also. All right, so this again, cyclic quadrilateral. So they're asking us to find the value of QRS. Now that is pretty straightforward. This is a 3 marks question, by the way, one for each. Okay, so QRS will be 107 degrees. Why? Because cyclic quadrilateral, the angles, so angle P plus angle R should be equals to 180 degree. So 73 plus angle R is equals to 180 degrees. So angle R is equals to 107 degrees. I hope this much is clear. Now, RQS. Okay, let's find out. RQS. Oh, so this angle they are asking. That's okay. I think this should be okay. Angle Q should be equals to what? 98, I believe. 180 minus 82 degrees, right? So 8 and 98 degrees. Now, one part of angle Q is already 55 degrees, right? This part is 55. So 98 minus 55 should give us what? Angle RQS, which is 8 minus 5, 3, 9 minus 5, 4. So 43 degrees and 107 degrees. These two parts, we have scored 2 marks by now, the third part, and we are moving towards scoring 3. So let's talk about this PRQ. Okay, so they want to join PR, which is fine, which is fine. So this angle is what they're asking. It means we need this angle. Now I keep making this conclusion every time. So I want you guys to know what I'm looking at and how I'm looking at. So this Deadpool mask you see, right? I mean, so what I usually do is this angle and this angle has to be equal. No matter what, it has to be equal, right? So that means that this angle, why are they equal, by the way? Angles in same segment, right? Because of this, those angles are equal. So I have to find this angle and I have to find this angle, right? Okay, so I can easily find, look at triangle PQS, 73 plus 55 plus angle, let's call this X, should be equals to 180. By now you have all known that I prefer X than writing PQ, PSQ. You can, in exams, you can still write X, but just be careful. In your final answers, do not write X is equals to something. We are habitual of that, but don't do that, okay? Because the question would never ask you X. Please remember that. X is your doing. You are bringing X into the game, so you cannot assume the examiners to assume that X is a correct answer. Okay, so 73 plus 5, so 55. So let's just see, 538 and 128 plus X is equals to 180 degrees. So X is equals to 180 minus 128. So 52 degrees is the value of X, and that means this angle is 52 degrees. So PRQ is basically 52 degrees. So we have just scored 3 marks in an actual board exam question. This was also again cyclic quadrilateral angles in the same segment, both taught in 9th grade to a fair extent. Okay, so be careful on this, guys. Okay, let's move to the next question. All right, this looks interesting. Okay, I can clearly see an isosceles triangle here. I hope you can all see now. So in the given figure, O is the center pretty much. And they are also saying QR is equals to OP. QR is equals to OP. Oh, that's fine. So QR is equals to OP is given. But what we know that OP is equals to OQ, right? Radii. That means we can also say that OQ is equals to QR. And that makes triangle OQR as isosceles. See? So now if this is 20 degrees, this is also 20 degrees, correct? So 20 plus 20 is 40. So therefore angle OQR here will be 140 degrees. Why? Because 20 plus 20 is 40, 180 minus 40 is 140 degrees. That means this angle will be 40. Angle OQP, sorry, angle OQP will be 40 degree. Why? Linear pair. Angle on a straight line is always 180 degree. So 140 was this side. So the remaining angle has to be 180 minus 140, which is 40 degrees. Okay. Also, we know that this triangle was isosceles. That means this is 40 degrees. Isosceles triangle have both the angles is equal. So 40 and 40 is 80. So you can say that in triangle OPQ, 40 plus 40 plus angle POQ should be 180. That means angle POQ should be what? 40 plus 40 is 80. 180 minus 80 is 100. So this angle is 100. And if this angle is 100, this angle is 20, and this whole thing is a straight line. So x plus 100 plus 20 should be 180 degrees. That means x is equals to 60 degrees. Now, how is this happening? Linear pair. Did I use anything related to a circle theorem here? No, not at all. When do you learn linear pair? Grade 7th all the way back. So, to reiterate my point, again, 9th grade theorems, general geometry, looking out for an isosceles triangle, alternate segment theorem, these are the concepts, these are the basis on which your board exams questions have been created over and over again. Okay, so I hope this is clear. We will move to another question. Okay, that's a good looking diagram. Okay, okay. So now, as we all know, that if you have a center here and a tangent here, at point of contact, we make a 90-degree angle, correct? Something similar is happening here. If you see here, this whole angle has to be 90 degree. Now, if you look at triangle OAC, I have 90, I have Y, I have X, is equals to 180. That means I have y plus x as 90 degrees. That's equation number 1. But I also have something more. Triangle BAD. So the big triangle. Now if you look at it, angle B plus 90 degree plus 55 degree should be 180 degree. I'm just using angle sum property. So 90 plus 55 is 145. So angle B is 35 degrees. 145 goes that side, subtracts from 180. So that means this angle is 35, correct? So 35 at the circumference. What will be the angle at center? You might have guessed 70 degrees, twice of it. So y is equals to 70 degree angle at center, correct? Now, if y is 70 degree, come back to equation number 1. What does it give? Y plus x was equals to what? 90. So x will be equals to what? 20 degrees. Again, this is a 3 marker. Okay. And what did I use? One tangent property. But other than that, angle sum property from a triangle's point of view, and angle at center and angle at circumference. So I used one 10th grade circle theorem, but I used two general geometry and grade 9th theorem. So keep in mind, guys, okay? This is on loop now. I don't want to bore you, but just keep in mind, okay? General geometry and 9th grade theorems. All right. So we're going to do this question, and let's see how to do this. Okay, so we have been given a pentagon, but we have been given a nice looking set of parallel lines too, which is good. So parallel lines, as you all already might know, parallel lines induce alternate interior angles, correct? So, I mean, I don't know about you guys, but for me, whenever I saw a set of parallel lines, the first thing that hits me always, 100% of the time, is alternate interior angles. So I have to, sort of, it's automated in my head. Let's see. The question says that AC is a diameter. You know what that means? AC being a diameter? That this angle is 90 degree, and that means this angle 90 plus 50, 40, 140. So this will be 40 degrees. And if you see, AE and BC are parallel, and they are forming, the AC is a transversal, so they are forming that Z shape of a parallel line, correct? So that means this angle is also 40 degrees. By what logic? Alternate interior angle. So angle ACB is equals to 40 degrees. What did I use? Semicircle I used, and angle sum property I used of a triangle, right? So ACB is 40 degree. EDC, let's see if we have found it. EDC, we have not, but AEDC, all 4 points on the vertices, it's a cyclic quadrilateral. So ideally, 40 degree plus angle EDC, because they're opposite angles of the cyclic quadrilateral, should be 180 degree. Why? Because cyclic property, right? So angle EDC will be equals to 140 degrees. So I will mark this as 140. Now they're asking us to find BEC. This was a 4-mark question, guys, by the way. BEC. So BEO, we will have to join BE and C. Okay. So they want us to find this angle. All right. I think this angle is 50 degree. See that Deadpool thing, this guy again, so this angle and this angle. So if you notice here, this angle was 50. So this angle will also be 50 degrees, right? Also, this angle was 40 degree. So this angle will be 40 degree. Again, angles in the same segment I'm using, guys. Nothing else, okay? This is, so we have 50 plus 40 as 90 degree, correct? So they asked us to find BEC. I have found angle BEC as 50, sorry, not 40, 50 degrees. How? Angles in same segment. Again, grade 9th guys. Also, if you see triangle BEC, because there is sub part to this question, BEC. Um, I have 40 degree, I have 50 degree, and I have angle BCE, and they should add up to what? 180 degree. That means 40 plus 50 is what? 90. We'll go that side. So what you observe here is angle BCE is 180 minus 90, which is 90 degree. So this whole angle, guys, is 90 degree. That means BE is a diameter. Remember, angle in a semicircle is 90. So if you have proven the semicircle angle is 90 degree, it means it is being made using a diameter, right? So B has to be the diameter, right? Again, cyclic quadrilateral, angles in the same segment, parallel line properties. Angles in the same segment, grade 9. Cyclic quadrilateral, grade 9. Parallel lines, grade 7th. I won't say anything after this. You're smarter than me. All right. So I think we will move to the next question. Okay. So so they have said that AB is a diameter. Immediately I will draw the 90 degree. Right? If you look at triangle ABD, angle D is equals to 90 degree, guys. Okay. So if angle D is 90, okay, what else they are saying? AOC is 72 degrees. That's fine. That means this will be 36 degrees. Angle at the circumference is half, right? So angle CBA is equals to 36 degrees. Sorry, 36 degrees. Half of center angle. Okay. All right. Now, they have said that AC is equals to BD. AC, oh wow, okay. Equal chords, guys. Remember, equal chords make equal angle at the circumference. So that means BD is making this angle at the circumference. And what is AC making at the circumference? Here, 36. That means this angle will be 36 degree. I will write that. Angle DAB is equals to 36 degree. Why? Angles made by equal chords. Okay. So we have this much information. All right. I think we have too much information now. This is 36 degree. Triangle OCB again is isosceles. It's almost boring now, I think. So isosceles, same segment, quadrilateral, diameter. I don't know what else to say. Please, if you are in grade 10th, you're writing your boards, please do not think that everything is related to grade 10th theorems only. This chapter is so important. And off late, I have seen in the last few year papers that it has been coming for at least 10 marks. Remember, your entire paper is for 80 marks, and circles could go as high as 10 marks. That is 1/8 of your paper. That's a lot. Okay, that's a lot, guys. 12.5% of your entire paper. So do not take it lightly. Okay, very important. Keep revising your normal geometry concepts. So we have 36 and 36. Okay, this angle will be 54. I'll tell you why. Triangle OCA is also isosceles. And as a result, what happens? I have 72 degrees. Then angle OCA plus angle OAC equals to 180. That means angle OCA plus angle OAC should be 172, right? So 108. So, and they are both equal. So therefore, they are both equals to 54 because of 108. Okay. So I think we can go in for the question now. We will see what are they asking. Angle ABC. Let's see. ABC. Oh, 36 degrees. So that's good. Angle BAD. BAD. Oh, that's also 36. And angle ABD. ABD. Oh, that the whole thing is remaining now. Right. Okay, so this angle was 18 degrees. Now you're thinking how 18 degrees? Let me draw this part separately, because this entire angle, guys, this is a passing line. So this is 36 degrees. This was 54, and this was equals to this, right? OAC was isosceles triangle, right? So this whole angle was 54. This part is 36. So what will this part be? 18 degrees. So I have to mark this angle as 18 degrees. Angle CB D is equals to 18 degrees. Why? Same segment. Again, guys, please pay attention, okay? A lot of ninth grade stuff happening here. So ABD, meaning the whole angle, this whole angle will be what? 54 degrees is equals to 36 plus 18, and that is 54 degrees. So again, a bunch of ninth grade theorems. Uh, dare I say that I didn't use anything related to 10th grade theorems here, actually, in this question. And this is an actual board exam question. So, again, all right, but this looks good. Important question, good question. It was for 4 marks. Um, let's move to the next question. Okay, so what do we have here now? Okay, so they are saying angle BCQ. I'm going to mark that angle very quickly here. 55 degrees. Now, if you see here, guys, OC is going to be perpendicular, right? Because OC is perpendicular to TQ, because radius is perpendicular to tangent, right? Now, that means this angle will be 35 degrees, right? So, angle OCB will be 90 minus 55, therefore 35 degrees. But triangle OBC and triangle OBA are isosceles. Don't we all know that now? Yeah. So this is 35. This is also 35. I hope you guys are not finding it boring, but these are important things, man. I can't really help. There is too much isosceles triangle happening here. Okay. So we have 35, 35. Um, They have also said BAP. So this angle as 60 degree. That means this angle is 30 degree. Why? Because this has to be 90 degree. OA is radius, no? So angle OAB is equals to 90 minus 60, 30 degrees, right? So OAB is 30 degrees. That means this is also 30 degrees. Isosceles triangle, guys. Okay. Now let's move to the question. So OBA and OBC. OBA, that is 30 degree. So angle OBA is equals to 30 degrees. First answer. Angle OBC. OBC. Okay. 35 degrees. AOC. Angle at the center. Come on. I mean, that has to be twice, right? So this whole angle B is 65 degrees, right? So angle AOC has to be 130. Why? Angle at center, right? So this angle is 130 degrees. That's your second answer. And ATC, ATC. Okay, this angle they are talking about. Oh yeah, that's again a very, very important diagram. Very important theorem, beg your pardon. So this, if you have this being the center, then you know that these two angles are supplementary, correct, guys? So if this angle is 130 degrees, angle at T will be what? 50 degrees. So angle ATC is equals to 50 degrees. Okay, so here, yes, I used quite a few of 10th grade theorems. I used the radius is perpendicular to the tangent at point of contact, angle at the center, and angle where both the tangents originate from. They add up to 180 degrees. So I think, yeah, 10th grade theorem was quite useful here. I can't say that it is again a very ninth grade oriented question. All right, let's move to this question now. Huh. Similarity. Oh, nice. Okay. So they're saying we have to prove triangle PAB and triangle PCD as similar. Wow. Okay, I can prove it in a million different ways, but we don't need that. Okay, we just need two angles, guys. I'm just kidding. Okay, you know that similarity needs only double A similarity by now. If you have done enough questions on similarity, you know that double A works like magic. It works more than anything else in similarity. So double A I have available because this is your Deadpool angle. Okay, remember, angles in the same segment. If I have to repeat it a million times, I'm going to do that. But please keep it in mind, guys. Okay, it's very important. Angles in the same segment. So I have two angles in the same segment itself. So I don't need to bother about anything else, right? Now, I don't know how you have learned similarity, but the first thing I want to talk about when I discuss similarity is that the outcome of similarity is the ratio of their corresponding sides. Very, very crucial. Okay, so the moment I prove triangle PAB, this is something that you should follow in similar triangles as well when you're doing that chapter. Okay, the moment you prove this as similar by double A, of course, you write PA, the first two letters by PC is equals to AB and CD. So AB by CD, the last two letters. And the first and third is equals to PB by PD. Now I have to find in the second part the length of CD. Where is CD? Here, right? I'm going to pick these two. So I will write PA by PC is equals to AB by CD. Uh, I think I might have picked that in a rush. I don't know. I mean, it will work or not. If it doesn't work, we'll go to this one. Okay. So PA, do I have PA? I have PA. That's brilliant. So 7.5. PC is 5. AB. Oh, that's nice. I picked the right one actually. 9. And CD is something I need to find, right? So CD. So that means CD will go here and 9 into 5 by 7.5. Okay. Okay. Let's make this 75 and 50, guys. Yeah, easy to calculate. So 25 threes are 75, 25 twos are, and then 3 threes are. So we have 6. The moment you land that answer, please mark it on your diagram. That's again a very, very important thing. Marking your diagram with whatever values that have been given, it's super important. Very, very important. It helps you in avoiding all that eye contact with the question paper. You don't have to keep going back to the question paper again and again. Make your diagrams self-explanatory so that you don't have to worry about a thing. Now, this is turning out to be more similarity question than really a circle question. Okay, so area of triangle PAB, I will not really get in details of similarity right now. I am assuming that your preparations are going good and what I'm going to write makes sense to you. Okay, so I'm just going to write here AB by CD square. All right. So if I have caught you off guard there, let me tell you, area of similar triangles, the ratios, is equals to the ratio of the square of the respective sides. So AB and CD are the last two letters. That's why I'm using it. And they are also nicer sides. I mean, I don't want to use 7.5. So AB is what? 9 and CD is what? 6. We just found it. So 3 threes are 9, 3 twos are 6. So 3 by 2 whole square, which is 9 by 4. The ratio is 9 is to 4. And this was a 5 marks question, guys. Very, very important. Okay. Came in one of the compulsory sections, I believe. They didn't have a choice in this question. So I hope this is clear to you. and moving to the last question of the day. And then I will again collect some questions. I am not done with circles, guys. We have at least 15 to 20 sums more to discuss from the previous year papers. This is only till 2020. I have started from 17. I've covered 17, 18, 19, 20. And after that, 21st and 22nd, we didn't have boards. There was COVID and everything. So those questions we will not discuss. We'll again go to 23 and 24. And then I'll go further back from 2017 as well. Okay. But this was an MCQ question. So this should not take too much time. So we are being asked to find angle PSQ. PSQ. Oh, this angle. All right. So, you have your this diagram again. Tangent and chord. So this angle is x. This should be also x. This is 30 here. So this should be 30. 30 plus 60 is 90. So in triangle PSQ, 30 plus 60 plus angle PSQ is equals to 180 degrees. So angle PSQ is equals to 90 degrees. Okay. So option number D is your correct one. So on that note, I'm closing today's session, guys. I hope you enjoyed the session. I hope you got to learn something new. If not new, at least something relevant from all these questions that we have talked about. I'll come back with more questions from circles. And after circles, we're going to talk a little bit about trigonometry, which is everyone's favorite, right? So till then, keep preparing for your board exams well. Stay calm. Do not over stress because you're not going to change the world by writing your board exams. Stay calm, okay? Everything will be fine. All right, guys. See you later. Thank you.